unbalanced system. For unbalanced system, what we have three different resistors, 600 ohms, 300 ohms, and 600 ohms. What's needed? I would like to connect them like that. And what else? I would like to do two different things. Use the neutral as the neutral for star is connected to the neutral for the source, and don't connect them. And measure the phase current for ABC, which is unbalanced system, and measure the voltage between phase A and B, and measure the phase current for each phase, and measure the voltage between the neutral for the source and N for the Y connection, and measure the current in that line, and also measure the power. So what I am going to do, I have these three different resistors. I'm going to connect them like what I said, Y. So I will connect this guy to this guy and this guy to this guy. I have here 1, 2, and 3, and the neutral. For the first part, with neutral, I will connect this guy. Without neutral, I will not connect this guy. Then I will connect this phase to this, and this to this, and this to this. And I need to connect a meter here, connect a meter here, connect a meter here to measure the line or the phase current. It doesn't matter because both of them are the same. And I would like to measure the voltage across this guy, the voltage across this guy, and the voltage across this guy. And then I would like to measure the power for one of the phases, for example, with and without neutral. Let us do that. So here, what I have, these are three different R. I will adjust them. So I need only 600. This guy is on. I need here 300. So this guy will be on only. And I need 600 for this. So I will start by connecting the Y connection first. So I'm going to connect this guy to this guy and this guy to this guy. Then I will connect those three to those three terminals and this to this. So I will connect this, this, and this. This is to the first one, and this to the second source, the second phase, and this to the third phase. And if I would like to use this circuit with neutral, so I will connect this to this. Without neutral, leave it like that. So we will apply first with neutral. So I will connect this to this. What do you need? I would like to measure the current, measure the current, measure the current. So I'm going to bring three different wires. So the first wire will be connecting between these two a meter. So I will connect the meter here. So I1 is measuring the current in phase A. And then the second wire, which is this guy, is going to measure the current in phase B. And the third one is going to measure the current in phase C. So I will put my meter here. So I1 is representing I phase for phase A, I2 is representing I phase for phase B, and IC is I3 is representing the current in phase C. I would like also to measure the corresponding voltage for phase A, for phase B, for phase C. So I will bring different wires again. I would like to measure the voltage between this and this, which is this. So I can connect it here. This guy is measuring the voltage between these 2 points, which is the voltage across phase A. So this guy. So right now I have this voltage. So P1, if I adjust it to measure P1, P1 is measuring the power across phase A. Because E1 and I1 are representing phase voltage and current. I'll do the same for phase B. So this guy will be connected, this guy will be connected where? Will be connected to this. And this guy, just 1 second, I would like to make it more clear. So I have these two. Let me change this because I don't like to have negative readings. So what I did here, I tried to connect the negative to, I tried to connect the negative to the neutral. So the negative is connected to the neutral. And this guy is the positive, which is connected to this. I repeat the same story. This guy is going to be connected to this. And this point is going to be connected to this point. So right now, I'm measuring what? I'm measuring the voltage for E2. I'm measuring the voltage for this phase. For simplicity, guys, instead of using this wire, actually this point is the same like this point because of this. And this point is the same like this point. So instead of using this wire and extra wires, what am I going to do? I'm going to remove this and connect this to this. Why? Because I would like to measure the voltage here. So the voltage here is the voltage between this one, which is this, and this one, which is this, which is this. So if I connected the voltmeter between this point, which is this guy, and this point, it is measuring the voltage across this. And by the same way, I'm going to do the same for this guy, this, and this guy. And again, I have the common neutral, which is this. If you try to go back here, guys, see voltmeter 1, it is connected to this point. Voltmeter 2, it's connected to this point. Voltmeter 3, it's connected to this point. And this and this and this are the same. That's why instead of using this guy to connect it to this, and this guy to connect it to this, and this guy to be connected to this, I did something which is more easier. So the second part for all of them is connected to this point, which is here. So what I did here, I connected those 3 points. You can do whatever you want. I'm trying to make it more easier for you. Right now, I have E1 is measuring the voltage across phase A, E2 phase B, E3 is for phase C, and I1, I2, I3 in sequence for phase A and B and C. What else is needed? I would like to measure the current in the neutral. What is the neutral? Actually, this is my neutral. Let me reconnect it again. This guy is my neutral. I would like to measure the current here. So for measuring the current here, what am I going to do? I will use another wire here. And in between these 2 points, I will connect a meter. So I4 is measuring the current in the line connecting this neutral to this neutral. This is IN. And last thing, I would like to measure the voltage between phase A and phase B. So I will bring this guy to be connected between this, and I will connect it here. So this guy is measuring the voltage between A and B. I can, instead of connecting it here, I can connect it there. It doesn't matter. It is the same. So this guy, like what you are seeing, is measuring the voltage between phase A and phase B. One more thing is left, which is the voltage between this guy and this guy. I'll do it later on. But let us right now to make our measurements. By the way, the power P1, which is representing the power in phase 1, the power P2 is representing the power in phase 2, the power P3 is representing the power in phase 3. Let me adjust this guy. So I have E1, E2, E3, E4, and I have I1, I2, I3, I4. So 1, 2, 3 are representing the three phases. And E4 is representing VAB. And I4 is representing INN. Let me make this power between active, and let me make this power also active, and I would like the power, I would like to measure the power. So let me turn it on. So this is the power that I got. So I can adjust this to measure by using digital and analog. So I did that intentionally to show you I can, for that acquisition system, use it to measure power by using analog system as well. Anyway, so here let me take picture for this, and here what I have E1 is equal to this guy, E2 is equal to this guy, E3 is equal to this guy. As what you are seeing, the source power is balanced system, and I'm expecting that because the source itself is balanced. They are approximately equal. And E4 is representing the voltage between two different phases, which is 212. But the problem is, since the resistances are not equal, the currents will not be equal. And this is what I would like to show to you. Here, I1 for phase A, 0.207, I2, 0.413, I3, 0.199. And the first power, 25, the second power for phase B, 50 point something, and the power for phase C, 24.15. And the total power will be the summation of those, if you would like to calculate it. What else is needed? The last part that I told you, I would like to measure, but I didn't do that from the beginning. I would like to measure the voltage between N and N. So I would like to measure the voltage between this guy and this guy. I didn't do that because the data acquisition system has only four different voltmeters. So I'll do that right now. What am I going to do? Instead of using this guy to measure the phase, I'm going to disconnect it and connect that between what? Between this and between this. So right now, I'm measuring the voltage between N capital and N small. By using what? By using E4. So I will look only to E4 here. I will turn it on and then I will refresh it. So this is E4, which is 0.158. Is it logic to have very, very small voltage? Yes, actually, I'm expecting the voltage is very, very small in case of what? In case of the line to neutral. So I'm expecting very small voltage, something like, in case of neutral, something around 0. Because the neutral current is very, very small. So the neutral voltage as well is very, very small. It is approaching 0. The neutral voltage is approaching 0 because the neutral current, which is this guy, is very, very small. And the resistance for the wire connecting the neutral to the neutral is very, very small. So like what you are seeing, I can say the voltage is approximately equal to 0 compared to E1, E2, and E3, because this voltage is 0.16, which is very, very small. So if you plug this number in the table, you can write 0, you can write 0.15, it is okay, 0.16, it is okay, because it's very, very small compared to this guy. I repeat the same story without using neutral. So I don't like to have a neutral in my circuit. So again, what am I going to do is I will turn this guy back, this guy, to measure the voltage between phase A and phase B, like what I did before, and then I will remove the neutral. What is the neutral? Actually, the neutral is represented by this guy. So this, I will remove it, and I will remove its ammeter because there is no current. So I remove the neutral right now. What am I going to do? Right now, I'm going to do the same, but I disconnected the neutral to the neutral, and I will measure the voltage between this and this to see the voltage between this neutral and this neutral in case of I didn't connect them. Let us see. But let us first see the values for the power, the voltage, the current, and everything. So let me turn this on again. And let me take one picture for that. Like what you are seeing here, what happens? Without neutral, the voltage values are changing. Why? Because in case of the neutral, the voltage to each phase is approximately said to be similar. But since we don't have neutral, the voltage values are changed. So the voltage for phase A is not the same like the voltage for phase B, is not the same like the voltage for phase C. And the currents also are not the same. And this voltage is the voltage between two different phases. And I don't have current here. Actually, there is no current for the neutral because the neutral is disconnected. And this is the power in case of different phases. So power P1 is 32.8, P2 27.9, B3 31.9. And this guy is representing E1, E2, E3, which are representing phase A voltage, phase B voltage, phase C voltage, and this is the voltage between two different phases. The current in case of phase A and the current in case of phase B, the current in case of phase C. Last thing I would like to do before leaving that, I would like to measure the voltage between this guy and between the neutral. I would like to measure this voltage. So I'm going to connect voltmeter between these two. So I will disconnect this guy, which is E4, and I will connect this guy between this point and this point to measure the voltage between N small and N capital. So my focus right now will be on only E4. I'm doing that to measure E4. Let me turn this guy on and refresh it. I'll keep a picture for that. This is the voltage between N capital and N small in case of we don't have neutral. In case of we have neutral, the voltage was approximately equal to 0. But in case of we don't have neutral, the voltage is equal to 31.19. This is the end for today's lab. But before leaving, I forgot to mention something as well. I'm sorry. So for the power also, don't forget to calculate P1, P2, P3 without neutral. So I will calculate the summation of the power with neutral and the summation of the power without neutral. So this is the end for today's lab. We have covered 3 different sections or 3 different parts. Part A, in case of we have delta connection, we measure the line voltage, the phase voltage, the line current, the phase current, and the power factor. And then we connected, in case of balanced system, we connected the circuit by using Y connection, and we did the same. And the last part, we tried to have unbalanced system, and we tried to see the difference between the balanced and the unbalanced system. Thank you for listening to that lab, and I'll see you for the next lab.